The topic that I will spend some time on today is advanced technologies in the aerospace sector. So firstly, before I get into the actual advanced technologies, it's important to understand one of the key factors that acts as an overriding factor in civil aerospace, and that is safety. So it's very easy to imagine the heavy processes and protocols that exist in this aerospace domain to ensure that this key factor, safety, is of paramount consideration in design and manufacturing process. Therefore, one will not see the kind of technological advances that you see in day-to-day world being incorporated as quickly in the aerospace domain. Also, not to forget that the big growth in civil aviation has been mostly fueled by low-cost airlines, which enabled a huge population in India and China to actually fly. Many people could only dream of flying maybe 20, 30 years back, but today they're all flying because of the low-cost airlines. Imagine if aircraft manufacturers and airlines were to invest more in new technologies. Their first consideration, obviously, would be return on investment, which would invariably increase airfares, which may bring down the growth in passenger numbers. So there is a catch-22 situation here, and we need to understand that. So I thought this would be a perfect disclaimer for some of the areas that I will touch upon in the next few minutes. So that said, there are areas where advanced technologies are knocking on the door to be incorporated in aerospace domain. So let me touch upon a few of them. Civil aviation, though one of the safest means of transportation, has had its own share of accidents. You all know that. Many of you must have watched aircraft investigations and wondered whether it's safe to fly. There is a very famous joke that says that the most unsafe part of your travel by aircraft is actually the drive to the airport. So that said, there have been a few accidents in the civil aviation sector. Analysis of these accidents have proved that almost 80% of them are caused due to human error, be it pilot or crew or maintenance team. Therefore, there is a crying need in aviation to reduce this human error. And in my view, artificial intelligence can be the next big thing to help the aviation sector. Use of big data analysis as a prognostic tool to predict failures, more automated landing and takeoffs, and I'm specifying landing and takeoffs because statistically, most incidents, aircraft incidents, have occurred immediately preceding or following a takeoff or landing. More robust airspace management, especially considering the growth of civil aviation and projected growth leading to dense airspaces, are some of the areas where artificial intelligence will make its mark in civil aviation in the near future. Another important factor that will drive aerospace technologies is environmental. Clearly, from fuel to ground handling to passenger movement, this is not the most environmental friendly sector at all. For example, we still use fossil fuel to propel most, if not all, civil passenger aircrafts. The fuel spent on ground between the time an aircraft pulls out of its bay to getting onto the runway is really a lot, and most of us are even unaware that a lot of fuel is spent during that time. And in busy airports, the time simply multiplies. So there is a screaming area for high technologies to be implemented, fuel being the big one. Hydrogen fuel is certainly seen as an alternative for now. I recently landed in Kochi airport in India, and I was surprised to see banners all over saying that's probably the only airport in India that is 100% sustainable. Apparently, it runs entirely on solar-based. The Bangalore T2 airport prides itself as being an extremely sustainable airport. So there's a lot of technology that is going in to make even our airports fully sustainable. Another area I will touch upon is passenger movement. Many of us discount the fact that passenger movement into and out of airports can actually add a lot to carbon emissions. And use of new technologies in these areas are probably a big thing. The last area that I will touch upon is fuel efficiency. Actually, there are three areas: fuel efficiency, weight reduction, and operational efficiency. All three of these are sort of conjoined in a sense because one actually impacts the other as well. Fuel efficiency, as you know, can be achieved through many means. More efficient engines, better fuel, lower weight, etc., etc. An example of being able to obtain better fuel efficiency is introduction of the new GTF engines by Pratt and Whitney. The A320 Neos, for example, most of them run on GTF engines, which huge leap in technology in the civil aviation sector, where the aim was to reduce both noise of the engines and improve the fuel efficiency. Better fuel, even within the fossil fuels category, is a constant area of research. There is constant research to try and see which fuels leave less residue, which fuels are more to manufacture, etc., etc. Even within the fossil fuels category. Coming to weight, you all are maybe aware that aircraft structures are today using carbon composite materials, which are much stronger, lighter than before. And more research is going on to make even more lighter and stronger materials. So that's a great area of technological advancement. On the electronic side, use of open hardware architecture and system on chips, etc., can reduce the overall size and weight of the equipment that are on aircraft. As you're aware, most aircraft are becoming more and more densely packed with equipment, keeping both safety and what shall I say, the pleasure or the enjoyment of passengers on board the aircraft. Making these lighter, making them more compact is definitely a major area of research, and a lot of technological advances are happening in it.